During the summer of 2024, Clallam County PUD began construction of a 115 kV switching station in Port Angeles, Washington. Located directly across the street from BPA Port Angeles, on property owned by Clallam PUD, the new station will be called Liberty Station. Liberty Station will accept a single 115 kV feed from BPA Port Angeles and split that feed into two Clallam PUD 115 kV feeders, Port Angeles East and Port Angeles West. Nearly 2 years went into the design, engineering, and planning for construction of the station. Over 100 pages of engineering drawings detail every facet of construction. Site grading and drainage drawings specify how the ground surface must be altered to meet the specifications required for the new station. Structural steel drawings detail the steel beams and columns that will support all of the electrical equipment within the station. The structural steel is prefabricated and received at the PUD's central warehouse facility prior to construction. Additional engineering drawings detail the layout of the station foundations, the electrical copper bus, perimeter fence, and conduit for the station control wires. Plans are drawn up for the station control house, which houses the station control relays. The control house is also prefabricated and delivered to the PUD's central warehouse prior to construction. Electrical drawings detail the electrical one line of the station, wiring schematics, and control relay panel point-to-point wiring connections. The control relay panels, which provide circuit protection to the two 115 kV feeders, are also prefabricated ahead of construction. Drawings for 115 kV circuit breakers and switches are received from the manufacturer and approved by the PUD. This equipment is purchased and received long ahead of station construction. Compound metering units, which measure the current and voltage at 115 kV for circuit protection, are received and prepared for delivery. The first step of construction is to clear the site of all brush and trees. PUD right-of-way crews make short work of the task. Olympic Electric of Port Angeles, Washington is selected by the PUD as the prime contractor for the job. Olympic Electric chose Interwest Construction Incorporated as their subcontractor for all civil work. A small fleet of construction equipment is brought on site to begin the task of site preparation. Overhead transmission wires are disconnected and brought down to make the area safe for all of the equipment and people working underneath of it. A new road providing access to the site and station is constructed coming in from the south side of the property. The local deer are unfazed by the heavy equipment and the noise of construction. A stormwater retention pond is installed on the north side of the property and will capture all of the stormwater runoff when it rains. Engineering drawings detail all the different concrete foundations required with rebar reinforcement and J-bolts for mounting structural steel. Holes for the foundations are excavated and correct depth verified with survey instruments. Carpentry crews then begin the task of fabricating all of the various wood frames with reinforcement into which the concrete will be poured to create the foundations. It takes a considerable amount of lumber to create the foundation frames, as well as reinforcements to maintain the frame when thousands of pounds of concrete are poured into it. Before pouring the control house foundation, conduit, which will bring control wires from electrical equipment in the station into the control house, must first be installed. Each conduit serves a specific purpose and must be installed precisely to reach its final destination. With all of the control conduits stubbed out, the control house foundation is ready to be poured. The next step is to install all of the concrete reinforcing rebar, some of which is pre-bent, into the foundation frames. Structural steel will be mounted to large diameter J-bolts. These J-bolts must also be installed into the rebar frame. The rebar cages are first started on the ground, tying each piece of bar together before being placed into the foundation frame. Once set into the foundation frame, crews set to finishing the rest of the frame, tying each piece of rebar into place one at a time. The top portion of the foundation, which is called a plinth, has its rebar installed with surrounding wood frame as well. The final layout of the station begins to take shape as each of the foundations are framed in and prepared to accept concrete. Ensuring that the J-bolts to which the structural steel will attach maintain their position precisely is of critical importance. Wood templates are installed over the J-bolts to help them maintain their exact position as the concrete is poured and cures. Surveyed string lines are used as a reference to measure the bolt locations. Prior to pouring concrete, the survey team from Clark Land Office verifies that the center of each mounting bolt is in exactly the right location. Surveying the center position of each and every one of the 120 mounting bolts, any discrepancies found are adjusted until each bolt is in precisely the right location. The foundations are now ready for concrete. Concrete pumping truck, capable of reaching each of the foundation locations, is brought on site by Angelus Concrete to execute the pour. Concrete mixing trucks bring the concrete to the pumping truck. The concrete is then slowly transferred into the pumping truck. With its boom extended, the pumping truck delivers the concrete to each foundation location. Crews then guide the boom to pour the concrete around the foundation frame, evenly filling it up from the bottom to the top, all of the way around the foundation frame. The concrete begins curing as soon as it is poured. Crews work swiftly and efficiently as a team to execute the pour as quickly as possible. One by one, the boom is moved to each foundation location and fills it with concrete. The pumping truck is an impressive machine, delivering 60 yards of concrete, nearly 250,000 pounds of concrete, in under 5 hours. The concrete is agitated with a vibrator as it is poured to remove any air trapped within the concrete. The pour is now complete. Crews next begin the task of finishing the surfaces smooth as the concrete begins to cure. Working together as a team, the control house slab is quickly finished to a smooth surface. With the first half of the foundations poured, crews begin work on constructing the remaining foundations, starting with the rebar cage. Some of the next foundations are round cylinders. The rebar cages for these cylinders are prefabricated and delivered to the job site ready to go. Cardboard tubes, called sonotubes, are the exterior frame for the cylindrical foundations. The sonotubes are set into the ground, rebar cages added, and structural mounting J-bolts carefully installed into place. Just as before, the location of all of the structural mounting bolts is of critical importance. Once again, skilled crews make quick work of delivering concrete to each foundation. The concrete is again agitated and then finished to a smooth exterior. With the foundations complete, all of the wood framing is now removed. The foundations are then backfilled with dirt, which is then compacted to stabilize it. All of the foundations are now complete. After letting the concrete sit for 1 week to fully cure, they are now ready to begin installation of the structural steel. Structural steel is delivered to the job site and staged for installation. One by one, each steel column is lifted into the air, moved into position, carefully set onto the mounting bolts, and then verified to be straight and true in the air with a level. In short order, the first 12 columns are installed and stand tall in the air. Repeating the process, the next and larger columns are lifted, moved into position, and set onto the mounting bolts. Like a well-choreographed dance, the process is repeated again and again. Liberty Station steadily moves forward in its march of construction. Skilled crews make hard work look easy. Crossbeams, upon which the electrical equipment will be mounted, are lifted high into the air and lowered gently into position, and then bolted to the supporting columns. The last of the support columns are massive steel beams over 30 feet tall and weighing 1,500 pounds each. The beam is carefully lowered into position. The process is repeated one by one, lifting up, setting onto the anchor bolts, and bolting down into place until the last of the support columns has been installed. The final piece of steel assembly are the cross beams to which the electrical switches will be mounted. These final pieces to the puzzle are lifted up and bolted into place. The structural steel installation is now complete. Next begins the task of installing all of the electrical equipment for the station to the steel. Flatbed trucks begin delivering the various electrical devices to the site. Crews remove the equipment from the trucks and set it aside to await installation. First items to be installed are 115 kV V switches, which are used to isolate equipment inside of the station for safety should that equipment require maintenance. In short order, the first two V switches, which each have 3 poles for 3-phase electricity, are installed. The second and last set of 2 V switches follows quickly behind the first set. The next equipment to be installed are 115 kV insulators, which will support the copper bus inside the station. The next equipment to go in are CMUs, or compound metering units. CMUs measure the voltage and current at 115 kV and generate signals which are sent to the protection relays, which monitor that voltage and current and open up the line in the event of a fault. These CMUs are massive devices, nearly 10 feet tall and weighing 1,500 pounds each. CMUs are also very expensive. Crews work carefully to lift each one safely into position. The next device to be installed is a circuit switcher. A circuit switcher acts just like a circuit breaker in your house, interrupting the flow of electrical power when opened. But a circuit switcher is designed to be capable of interrupting up to 1,200 amps at 115,000 volts of electrical energy, enough energy to power nearly 10,000 homes. The V switches are tested to ensure that they are operating correctly. Installation of all of the electrical devices is now complete. 4 individual V switches, 2 circuit switchers, 6 CMUs, 12 insulators, and 3 lightning arresters. The next phase of the project is installation of conduit for the control wires. Control wires connect the CMUs and circuit switchers in the station to the circuit protection relays in the control house. Ditches are dug for the conduit, and the conduit is then installed into the open ditch. With the conduit installed, the ditch is then backfilled with dirt. Swiftly marching on, the next task is installation of the transmission wires that will connect the station to the existing transmission lines and to BPA. 795 AAC wire is a big wire capable of carrying a significant amount of electrical energy. Dead-end bodies, which are used to connect the transmission wire to the equipment in the station, are hydraulically compressed with up to 10,000 pounds of force to permanently crimp the dead-end body to the transmission wire. This ovali is what attaches to the equipment. The wires are lifted into the air. One end is attached to an insulator on the steel structure, and the other end attached to the circuit switcher. Wires which will connect to the existing transmission poles out on the road are also attached to insulators and coiled up awaiting the next step of installation. Additional wires bring the 115 kV BPA transmission feeder from BPA Port Angeles into Liberty Station are also installed. The final transmission wires to be installed connect Liberty Station to the poles supporting the transmission line east and west feeders outside of the station. The next step of construction is installation of the station ground grid. The ground grid is a critical element in the safety of the station, bonding all of the steel support structures in the station to the earth. In the event of an electrical failure, the electricity will be safely diverted into the ground. Trenches are dug in a grid pattern throughout the station. Copper wire is then pulled out from spools and laid into these trenches. Once the wires are laid into the grid, they are then joined together using compression crimp fittings which permanently join them together. Ground rods are another key element to the function of the grid and are driven deep into the earth, dispersed throughout the entire grid. The ground wire is then connected to the ground rod using a device called a CAD weld. A CAD weld is an exothermic process wherein a ceramic cup is placed around the rod and wire. A powder charge is then placed into the cup and ignited, effectively welding the ground rod and ground wire together. PUD maintenance crews begin installation of the perimeter fence around the station. The fence perimeter is 140 feet by 140 feet square. A total of 54 metal posts must be set into the ground. The long line of fence posts quickly takes shape. Meanwhile, Inner West construction crews begin the task of installing the base layer of crushed rock in the station. This crushed rock is another element to the safety inside of the station, providing an insulating base layer throughout the entire station. To cover the entire station, over 600 tons of crushed rock is hauled in and spread throughout the station. One truckload at a time, more than 40 dump truck loads of rock in total. Steadily marching on, the rock is dumped and spread throughout the entire station. Meanwhile, PUD maintenance crews continue installation of the chain link fence. A total of 560 feet of fence must be installed. The fence rolls are brought on site, lifted from the truck, and then laid out onto the ground around the station perimeter. Working efficiently as a team, PUD crews get the chain link fence up in short order. Using a come-along, the fence fabric is pulled up good and tight, and then securely attached to each of the individual fence posts. PUD substation crews set about the task of pulling in control wires. A true tape is first pulled into the conduit to determine the exact length of wire needed. The wire is then cut to length, laid out on the ground, and then pulled into the conduit using a pulling tape to pull it in. Meanwhile, PUD maintenance crews have completed installation of the fence around the perimeter of the station. Substation crews complete the task of pulling in all of the new control wires. The relay control panels are installed inside of the control house. A battery charger and battery bank, which will power the station in the event of a power outage, is also installed. The control wires are cut to length and methodically terminated in each of the field control devices. Inside of the control house, the control wires are prepped for termination to the relay control panels.
Landing the control wires for the
Lastly, the control wires are terminated on the control panels. This is precision work. Each and every wire must be landed in the correct spot for the system to function as designed. Verifying each wire against engineering wiring diagrams, skilled substation crews make short work of the task. With just a few tasks ahead yet to complete, Liberty Station is rapidly approaching the finish line. The control house is connected to the PUD's internal intranet via fiber optic cable. This will allow monitoring and control of the station from the PUD's engineering offices. The fiber optic cable must be spliced into the PUD's main trunk line. This fragile glass wire is carefully prepped and then cut for splicing. The second fiber line is also prepped and cut for splicing. The cuts to these glass wires must be perfectly perpendicular for the data signals to properly pass through. A precision instrument verifies that the cuts are correct before splicing.
Into the tray.
Once everything is correct, the glass wire is heated up and fused together to create the splice. A heat shrink tube is then placed over the splice as the final step. As part of the station commissioning, the circuit switchers are operated to verify that they are wired correctly and open and close when commanded to do so. The next step in station commissioning is to verify that the current transformers are operating correctly. A test instrument capable of injecting several hundred amps of current is connected to the CMU. Current is then injected into the current transformer, simulating a live line with load, and then verified at the protection relay that it is operating as expected when the protection relay reads this injected current.
What are you giving me?
What do you got?
I got 107.4.
Additional checks with the multimeter at the back of the control panel measure that the signals fall within the expected range to verify that they are correct. Clallam PUD's relay technician enters all of the settings into the protection relay and then tests that they function as expected. These settings determine when the line will be de-energized in the event of a fault on the line. Nearing the end, substation crews install the copper bus, which will connect to the BPA line feeding the station and then carry the electrical energy into the station, one stick at a time, 3 phases per feeder. The copper pipe must be carefully cleaned and coated with conductive grease before bolting it to supports on top of the insulators. The final step in construction is to connect the station to the BPA lines, which will deliver power to the station. Ropes are used to measure how long the wire jumper must be. This rope is then used to measure and cut the jumper to the proper length. The wire jumpers are then lifted into the air by 2 linemen in bucket trucks. The ends of the wire are first cleaned to ensure they are free of any debris, and then inserted into the connectors which hold them and bolted tight, securing them into place. Liberty Station is now connected to BPA. Construction is complete, and the station is ready for service. From computer design to finished station. From bare green field to fully energized 115 kV switching station. Liberty Station is online, bringing clean, reliable energy to the residents of Clallam County for many years into the future.